A very good morning, good afternoon, good evening to all my dear students, participants. This is the course Multi-Criteria Decision Making under NPTEL MOOC. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur in India. So, as you know that this total course is for 60 lectures spread over 12 weeks, and each week we have 5 sessions or lectures, and each lecture is for half an hour. The broader ideas which we are still considering is multi-criteria decision making, and ideas we are still discussing for a long time in the weeks of the classes, multi-objective decision making. Then we will consider multi-attribute decision making, multi-attribute utility theory, and then go into the concept of more qualitative decision making in discussion. This is the 34th lecture on the 60 lecture series course. Now, as we were discussing in the last class, we were discussing linear programming with 3 objectives, and they were marked as F1, F2, F3, and to make things more clear, I have used different coloring scheme: red for the first one, violet for the second one, and blue, light blue for the third one. Constraints are same. And also I did mention they were all 3 were maximization. The question can be easily answered. They can also be considered as minimization or combination of maximization and minimization. The idea remains same. In the first problem, we considered objective function 1 as to be optimized, which is maximized, and constraints already existing were increased by 2, in the sense the second objective came as a part and parcel of the constraint, the third objective also came as a part and parcel of the constraint, and we will continue the same logic for second problem solution, third problem solution. So, thus to make things move in the line right direction, 3 objectives F1, F2, F3 as shown. So, this was F1 in red, F2 in violet, F3 in blue. These are the constraints. We maximize them separately, and has the results are F1 star red for first objective, F2 star violet for the second objective, F3 star blue for the third objective. This was the solution for the first, this was the solution for the second. This means you have already seen it, so I am not repeating it. For the first objective, the solution points, decision points was 20, 0, 0, objective function maximum was 40. For the second objective, which you are seeing now, is the solution of decision variables are 0, 20, 0, maximization is 40. For the third single objective, the solution points are 0, 0, 20, and the objective value is 40. Now, as I said, I consider, which we are solving the last day, in the last day means the last lecture, we consider objective function 1, which I will mark as OBJ number 1, which is red in color. The constraints 1, 2, 3, 4, 1, 2, 3, 4 are there. Fifth is here, and the sixth and the seventh, which is the additional one corresponding to objective function 2 and objective function 3, are shown in the corresponding color, which is sixth in violet I am writing, and it is another is the blue one, which I am writing seventh. They are all less than with their corresponding F2 star and F3 star. Y less than, this is the objective function to be maximized. So, we will consider them accordingly. We took different values of delta 2, delta 3, which were to be subtracted from F2 star and F3 star. The combinations are given in the first 2 columns. Column 1, which is for delta 2 violet color, column 2 delta 3 in blue color, and the combinations of x's are given in the third column with F1 double star, which is the corresponding changed values of objective function 1, are given in the first column. So, this is the so called solution of the first objective, considering second and third objectives are in the constraint. So, correspondingly we take other combinations of delta 2 and delta 3, and these are the 40 minus delta 2, 40 minus delta 3. So, the delta 2 and delta 3 are given, column 1, column 2. Based on that, I have the solution which is in column 3, and the finally F 1 star double star in the column 4. They have been solved using simple linear programming problem. Having said that, now we go into next stage. Next stage or second case in the next stage. Next stage I actually should be technically to be right. Next stage is where we are solving each objective function in the objective cases, and the left out objectives are being dragged into the constraints. So, this is the formulation of objective function 2, violet in color, the existing constraints, I will use a green, 1, 2, 3, 4 and the fifth one. The sixth one is shown here, and the seventh one is shown here. I have used coloring scheme to make things clear, and here also it is F 3 star minus delta 3 and F 1 star minus delta 1. So, this is delta 1 in order to avoid any confusion, the coloring scheme. So, when I solve it, interestingly the answers I get. So, these delta 3 and delta 1 are the corresponding values of delta which are to be subtracted from the third objective function which is there in the constraint, and the first objective function which is there in the constraint. So, that is why the coloring of blue and red. So, these are the values of 40 minus here, is 40 minus 22, 40 minus 23, 40 minus 25, 40 minus 25, 40 minus 22, 40 minus 25, 40 minus 27. Here also 40 minus 22, 40 minus 23, 40 minus 25, 40 minus 22, 40 minus 25, 40 minus 27, 40 minus 25. When I solve it, the corresponding values of x 1, x 2, x 3 are given here, third column, and the value of f 2 double star, which is for the second objective, and double star means because as they are changing, are given as here. So, if you see the values of 39, 38.5, I am reading the last column, would almost be the same, but the combination of x 1, x 2, x 3 would change, and I will come to that. Corresponding to more such combinations of delta 3 and delta 1. So, we have again these are all 40 minus. So, this would be 40 40 minus 30, 40 minus 27, 40 minus 30, 40, 40 minus 37, 40 minus 39. On the right hand side, we are related to the first objective being brought in the constraint. Again 40 minus 27. So, this would be again I am repeating right hand side, I will write it. 40 minus 32, 40 minus 30, 40 minus 37, 40 minus 35, 40 minus 39. So, let us take one of these. I would also do it for the first example under case and the second stage. Second stage problem means maximizing single objective with the other objective being brought into the constraint. So, if I consider this, so actually this 40 minus 30 is I write it with different with the blue color is 10, and 40 minus 32 is 8. So, what does 8 and 10 mean? So, 8 and 10 would basically mean this for objective function 2, this 8 and 10 this is less than equal to f3 minus 30, which is 10, and this would be 8 less than equal to 8. So, based on that we will solve it. Similarly, if I consider this, say for example, arbitrarily let me consider different value 25 for example. This is the objective function 1 with objective function 2 and 3 in the constraint, this one. So, this would be a violet color, 40 minus 25 is equal to 15, and for the blue one, which is the third objective, 40 minus 25 is 15. So, if I go back to the problem, this is objective function 1, this is equal to less than equal to 15, this is equal to less than equal to 15, and we will solve the problem for objective function 1. Now, we go into the last objective function, which is the third problem under stage 2 or case 3 for stage 2. This is the objective function which is f3, which we all know. So, I will just write obj objective 3. Constraints, this is 1, we already know this is 2, known to us 3, 4, this is 5, and the red one and the blue one which are corresponding to objective function, this is again my mistake, this should be 1, which are corresponding to objective function 1 and 2 are as follows. So, this is the sixth one, and this violet one is the seventh one. So, with this I solve the problem. Again I take lambda 1, lambda 2 as the part to be subtracted from f1 star and f2 star. So, these values would be, I am again writing 40 minus 22, 40 minus 23, 40 minus 25, 40 minus 25, 40 minus 22, 40 minus 25, 40 minus 27. If I come to the second column, which is related to the second objective function being pushed into the constraint, again it is 40 minus 22. So, this 40 value which I am writing is just a coincidence, because I framed the problem very simply, so that everything can be understood. 40 minus 23 for the second, 40 minus 25 for the third, 40 minus 22, 40 minus 25, 40 minus 27, 40 minus 25. So, if I take any one set which we will solve, For example, this one, first one, the values I'll write it, but the values if I for all of them are given here. Third column, the objective values, which is F3 double star in blue, is in the last column, and continuing different values being subtracted from F1 star and F2 star, which are red and violet. The corresponding values to be subtracted from 40 are 30, 27 correspondingly. I am not writing it, 30, 32, 35, 37, 39. So, all have to be subtracted from 40. And for the other objective function, which is the second one, the values to be subtracted in 40 again are these 27, 30, 32, 30, 37, 35, 39. The corresponding solution when they are solved, these are x1, x2, x3 values, and the last common R values are the F3 star, which is the double star, which is for the third objective. Now, coming back here, I mark this 40 minus 22 and 40 minus 22, which would be 18 in both the cases. So, if I put in this equation, so this would be less than equal to 18, this is the one, and this would also be less than equal to 18, because they have been formatted accordingly. Why 18? Because they are 40 minus 22, 40 minus 22. Now, where are the important, and this I will try to highlight using a diagram. I will add a blank sheet and draw it. So, let me draw it. This is x3, this is x2, this is x1. Now, the solution, if you remember, was 20 0 0 0 20 0 0 0 20. So, that is basically, I will draw one by one. The points are coming out to be, first objective we used red. So, they consider this is, here is the point. Second objective was violet, third objective was basically shown in red, blue, so technically the points are these. Now, if I solve the problem and as given, let us go one by one. The value of the first objective, consider, say for example, consider is this one. So, I will use the red color because objective function 1. So, I will use 37.5. So, it is 17.5, 2.50. So, 17.5, 2.5 for x2 will go a little bit in this direction, and for x3 0. So, it will be on the flat plane x1 x2, no delta movement in x3 direction. So, this is the point 1, and the value, if you remember, I will write it here 36.5. So, let us hunt for 36.5 for objective function 2 solved with objective function 1 and 3 in the constraints. So, this was objective function 2 with objective function 1 and 3 in the constraints. For 36.5, it is correctly, it was 3.5, sorry, not 2.5. For 37.5, it was 2.5 and 70.5, and 36.5 is 16.5 and 3.5. So, I was, so it is 16.5, 3.50. So, this is the 16.5 3.50. So, I am not considering this one, it's my mistake. So, that was objective function 1 f1 red. Now, for objective function 2, which is f2 invalid, this is this value 0 16.5 3.5. So, 0 16.5 it is this and 3.5. So, it will basically be here. So, this will be 16 0 for x 1, 16.5 for x 2 and 3.5 for x 3. So, these are the points, this is the point. And lastly, when I consider x 3 to be in the other point. So, I am taking the combinations and drawing it. I am not drawing x 1, x 2, x 3 as such. I am drawing only those combinations which gives me same values for f 1, f 2, f 3. When I solve the third objective function with the first and second in the constraint, for 36.5 I will mark in blue. This one I am taking this 3.5 0 16.5, 3.5 0 for this 16.5 would be on that plane. So, first was on the bottom plane, if I consider where I am standing, where the axes are x 1 x 2, and then the second point which is shown in violet is on the left wall. If I am standing in a room, is the left wall, and the third point which I just mentioned is away from me, that means between you and the participants and me. So, this is the 90 degrees and the base is there, floor, wall 1, wall 2, and in the floor x 3 is 0, because we have measured x 1 along this direction from my left hand to the right hand, x 2 is from the camera towards me or from you towards me, and x 3 is from, if I consider the vertical height, from the base going up. So, if I plot it, the point, so the points were basically 3.5 on x 1, x 2 is 0 and x 3 is 16.5. So, this will be somewhere here. So, the first point which is red, I will mark in red because it is related to the 1, then the violet one which I will use as 2 and the blue one which I will use as 3 are for the case when the objective function values are 36.5. So, they are actually nothing to do with Pareto points, but I am just showing. Obviously, there will be more analysis. So, if I join, so technically I have not solved it, I can plot such points where the value of these individual functions are 36.5. So, this I should also write. and I can solve them to find out. Now, the issue is that can we find a set of answers for x 1, x 2, x 3 such that the values remain the same and we get the points according to the case where the objective functions are fixed. So, we will consider that, because considering even though there are 2 minutes left, 2.5 minutes left, but considering that you have to go in depth into the problem and understand and analyze that problem separately. Now, the diagram which I have drawn, the question is that can we do the same for other points? Yes, we can do the for the other points. If you see, for f 1 I have only considered 36.5, but there are other sets of points also which gives me, and similar combinations are available for f 2 star, double star, star. So, using this, and this is a 3-dimensional one, it is easy for us to understand. We can consider different problems accordingly. Thank you very much and have a nice day.